Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. In this lecture video series, Statistical Data Representation, first we are going to see a design thinking based video. Let us see what is design thinking first. Design thinking is a 5-stage process in which empathy, define, prototype, ideate, prototype and test are the stages. So first let us see understanding frequency distribution through design thinking. So transforming complex data into clear, actionable insight using human-centered design thinking principles. First, see the empathize part. So why frequency distribution matters. Data overwhelm in real. Raw number fled over daily work, sales figures, survey responses, test scores without organization. Valuable insights remain hidden in chaos. So next second one is pattern tell stories. Frequency distribution organize data into meaningful groups, revealing trends and patterns that guide strategic decisions. Next is business impact. A car dealership analyzing 500 vehicle prices discovers their sweet spot for inventory planning and targeted marketing. So understanding your audience relationship with data is the first step to creating meaningful visualization. Next is define part, in which the challenge of making sense of data. How might we transform overwhelming data set into clear, actionable insights that anyone can understand? First is user pain points, information overload for raw data, difficulty spotting trends quickly, need for intuitive summarization. Second one is success criteria, clear pattern recognition, faster decision making, accessible to non-experts. Third one is an ideate step. What is a frequency distribution? A systematic method to group data into classes or categories, showing how often specific values occur within a data set. So as we all know that a frequency distribution is divided into 4 categories that are grouped, ungrouped, relative and cumulative. In short, ungrouped frequency distribution is an individual data set value. Next, grouped is a continuous variables. Next, relative which shows proportion or percentages instead of raw count, great for comparing different sized groups. Next, cumulative, so running total that help identify thresholds and percentile ranks within your data. Next is a prototype part, in which building a frequency table. So determine class. Use the 2 power k greater than n rule to find optimal number of classes for your data sets. Calculate with class interval with maximum minus minimum divided by number of classes. Next, set boundaries. Define clear class limit, ensuring no gap or overlap between intervals. Next is tally and count. Sort data points into classes and count frequencies for each interval. Here is an example in which 7 classes, 2 power 3 which is equal to 8, which is greater than 80. Next, rupees 3000 interval with $3,000. Range is $15,000 to $36,000. Next is visualize graphical representation. Transform your frequency table into compelling visual stories that reveal patterns instantly. First one is histogram, second one is frequency polygon, third one is pie chart. So histograms are used for showcasing the perfect class interval frequencies. Next, polygons, this is line graph connecting class midpoints. Next, pie chart, so relative proportions of categories. Next one is real world applications. This is the test part. So key insights. Meitner autoplex data reveals $21K to $24K range as their sweet spot, enabling focused inventory management and targeted marketing campaigns for maximum ROI, that is return of investment. Next is implement, applying frequency distribution in your work. Surveying analysis, summarize customer satisfaction scores, demographic data or feedback rating into actionable insights. Next is sales performance, group sales data by regions, time period or product categories to identify top performers. Next is quality control, monitor manufacturing defects, response times or any measurable process variables. So pro tools are Excel for basics, Python matplot library for advanced analysis, or BI software like Tableau for automated dashboard and real-time insights. Next is prototype, defining insights with advanced frequencies. So first one is relative frequency, second one is cumulative frequency. In first we can see 25% of sales. In second tier it is 18%. Next, cumulative frequency, 50% of vehicles sold under $24,000. 75% of inventory priced between $27,000, and 95% of sales occur under $33,000. Next is conclusion. So design thinking unlocks data clarity. So first is empathy, which is understand user needs for data clarity. Next is define, frame the data complexity challenge. Ideate, explore frequency distribution method. Prototype, build and test distribution tables. Next is visualize, create compelling data stories. Next, in iterate, define insights continuously. So the frequency distribution transforms overwhelming raw data into powerful actionable stories that drive the informations clearly. Thank you.